Hey, what's up? You notice some changes to my render window, and I'm going to provide a snapshot to every major change that I make to it so that you can inspect it, and it's going to go on my website. But here is the differences. I've got these follower sprites that follow the mouse. Some of them move a bit slower than others, and they all start at different positions when the form starts up. And then up top, the form's text property displays the width and height of the form as well as the frame rates, or the frames per second. You'll notice the orbit sprites, they kind of just orbit around the follower sprites. And we'll talk about the sprites right now. Okay, we'll start off with the normal sprite. Of course, you got the size and location, and then I've decided to collaborate the two into a rectangle called bounds. And this will just allow you to paint a bit more efficiently because you're always going to use a rectangle to draw something, or for the most part, simple things. Let's go to the follow sprite. And you'll notice right off the bat that you have the two orbit sprites within a follow sprite. And then I'm going to instantiate the two follow sprites and pass in I'm going to instantiate the two orbit sprites and pass in the current follow sprite. One of the orbit sprites needs to be adjacent so that it's not in the exact same position. Okay, so the set speed and set location methods, those are down here. And these methods call a random function that is just kind of out there in my music class. If you use the random method if you use the random objects within the methods, you'll notice that you'll have seed problems and your random values will turn out all the same. So I simply created a random object in my music class, and then I've created two static methods that utilize this random object. That's the only way I could get it to work properly without having seed problems. So I hope you have good luck with this as well. Okay, so back to the follow sprite. So the first thing that I'm going to do is I'm going to set the destination of the follow sprite, the point where it's going to try to follow. You'll notice that I'm using the form active form property to access the size of the form. And when you're doing this, you always have to check for null, because if the form loses focus, it will no longer be the active form, and active form will be null. You'll have a big red X on your window. Okay, so I'm setting the destination by getting the cursor position and changing it to point coordinates instead of screen coordinates. Then I'm going to reconstruct the destination point to be centered. So you notice down in the move to destination method, I am using just a cheap non-vector way of moving the follow sprites towards the cursor. And I'm also checking for boundaries so that the particles don't exit the bounds of the form. When you're doing it this way, you'll notice that you get a bit of flicker with your painting because the sprites are moving back and forth very quickly instead of stopping when they get close to their point. That's what you get for using this kind of logic. But I do use a vector class that I made a long time ago with orbits. You can't really do anything circular without having a unit vector of some sort. So you'll notice that in this draw method here, I'm calling draw for the orbit sprites. So when you're deriving your sprites, you want to draw all of the inner sprites within that sprite. So if I had sprites properly constructed in the orbit sprite, then all of those sprites would be drawn as well simply by calling draw here. Okay, so this set position method is something that you might be interested in. I'm first seeing if the degree integer is greater than or equal to 360, and if it is, I'm going to reset it to 0. Because I've created a unit vector class that can use basic degrees instead of radians. And if it's not greater than 360, then I'm simply going to add the move speed multiplier of the current object and then times it by the render time. And that will allow me to properly adjust the speeds of the orbit. Down here, I'm simply constructing a center point for the orbits to rotate around. Then I'm going to create a new instance of my vector class, pass in the center point. I'm going to specify that the orbits are going to be 30 pixels out from the center point, and then I'm going to pass in the degrees integer. And then I'm going to retrieve the endpoint property of the vector, which is something that's calculated within the vector, and it's very useful. And the endpoint is going to be the location of the orbit. At the time, my unit vector is kinda broken. You do have to recreate or reinstantiate the object every time you want to use it. My initial intentions were to be able to set the endpoint property and to be able to set the radians and the degrees separately from each other and have the entire unit vector adjust appropriately, but it never really worked out. So I'll probably get around to that sometime after I'm finished playing around with the render loop, but it's definitely something useful when you're doing anything circular or path oriented. You're extremely limited to what you can do in game programming without vectors or vector methodology. Some other stuff that might be worth mentioning is I've added the control styles opaque flag to my set style method here, simply because we do not need to paint the background. And I have this check for debug mode, so when I'm in debug mode, the form will not be full screen. So I'm basically just saying that the window state should be normal and the form border style should be sizable. By default, it is the complete opposite. I've increased the quality of the back buffer by using a 32-bit per pixel RGB bitmap, and I'm also accessing a couple properties of the back buffer to increase the quality by setting them to their corresponding high quality enumeration. And you don't need to do the same for the front buffer because the front buffer is simply being used to paint the canvas, and that's it. I also have an abstraction of the anti-aliasing here. It's just a property in the Physics class that allows you to change this very quickly. When you're drawing to the screen, always make sure that you use Draw Image Unscaled for performance. You do not need to scale the image. You'll notice that I'm using milliseconds now with my elapsed time counter, and within this every second if statement here, I'm actually firing an event that can be handled from anywhere, which is pretty useful, and you don't need to use offbeat timers or anything. And I am calling application do events. I do not believe you need to do this. This can actually significantly decrease the performance of your render loop, but sometimes it's necessary if you're using a lot of Windows Forms stuff that you're not supposed to be using. Right here I'm using the visible clip bounds of the back buffer to get the width and height of the client rectangle of the form. This is an alternative to getting the active form of the main form or passing a reference to a static class of the main form or anything like that. It's pretty okay. So I'm going to be implementing a ton of random stuff in this render window, and I'm just going to make unnecessary use of GDI to render stuff to the screen, and I hope that you can learn something from it.